Welcome to an architecture-first journey through ISO IEC 42001. In this course, we'll connect AI governance to real solution design, lifecycle controls, MLOps, risk management, audit evidence, and certification readiness, so you can lead implementation with confidence. The course moves from ISO IEC 42001 foundations into governance, risk, architecture, operations, and audit readiness. Along the way, each module builds practical artifacts you can reuse. By the capstone, you'll connect architecture decisions directly to certification evidence. Plan on about 40 to 60 hours depending on how deeply you practice. This course is designed as a progression, not a checklist. We begin with the foundation, what ISO IEC 42001 asks for, and what an AI management system actually manages. Then we move into governance, where risk, accountability, impact, and regulation shape decisions. From there, we design controls into the architecture of data, models, LLMs, oversight, transparency, and lifecycle processes. Next, we operate those controls through MLOps, observability, security, and incident response. Finally, we produce evidence, assess gaps, prepare for audit, and apply everything in a capstone case. The goal is certification readiness through working system design. Use this course in a way that matches your starting point. If you are newer to ISO management systems or AI governance, move sequentially and do not skip the foundation. Build the vocabulary first, then connect each concept to an AI system you know. If you are intermediate, stay with the sequence, but spend more time where governance becomes architecture, controls, and operations. If you are advanced, treat the material as a reference library. Push each requirement into a design decision, evidence source, or procedure. Keep an implementation notebook and keep asking, what would I show an auditor? Now we move from orientation into the first foundation topic. We'll look at why AI needs a dedicated management system, what an AIMS is meant to govern, and where ISO IEC 42001 applies across the AI lifecycle. Keep the architect's lens in mind. Requirements only matter when they become real controls. Traditional technology management often assumes systems are mostly predictable, owned, and controllable. AI challenges that assumption. Models can be probabilistic, data-dependent, opaque, and connected to outside services. That creates risk for compliance, security, business processes, and public trust. ISO IEC 42001 helps turn that uncertainty into a governed operating model. It asks organizations to manage AI across the full lifecycle, with ownership, controls, monitoring, evidence, and improvement. For architects, it links governance expectations to design choices, so responsible AI becomes engineered practice, not informal hope. An AI management system, or AIMS, is the operating model that makes responsible AI manageable. It is not just a binder of policies or a compliance checklist. It defines how AI goals are set, how risks are assessed, which controls are required, who is accountable, and what evidence proves the system works. Just as important, it connects teams that often work separately: leadership, engineering, legal, security, operations, and the business. In ISO IEC 42001, the AIMS becomes the backbone. It gives the organization a repeatable way to govern AI today, monitor performance, and improve as systems and risks evolve. ISO IEC 14001 does not assume that every part of the enterprise is automatically covered. The organization defines the AIMS boundary deliberately, based on where AI is provided, built, deployed, operated, or monitored. That boundary may include AI systems, business processes, data pipelines, model services, and operations. It may also connect to external platforms, integrators, third-party services, and contractual obligations as interfaces or dependencies. Architects are essential here. They clarify system boundaries, ownership, integration points, data flows, and lifecycle responsibilities, so the scope is practical, auditable, and aligned to real risk. Before you map controls, clarify three things. First, purpose. Why the AIMS exists. It may support certification, regulatory alignment, trustworthy AI governance, risk reduction, or consistent enterprise controls. Second, scope. Which AI systems are covered, such as products, internal tools, Gen AI apps, ML pipelines, platforms, or specific business domains. Third, boundaries, where your responsibility ends and an external dependency begins, including APIs, foundation models, cloud services, vendors, and human decision points. Weak scope weakens evidence. Clear boundaries make accountability, risk treatment, and audit preparation much stronger. ISO IEC 426D1 becomes architectural when governance requirements turn into system capabilities. As data enters the pipeline, architects need lineage and provenance. As data is prepared, they need quality gates. During training and fine-tuning, approval controls define who can proceed and under what evidence. Evaluation adds validation before release. Deployment and inference require human oversight, security controls, and transparency mechanisms. After launch, monitoring checks drift, bias, performance, misuse, and incidents. The key design test is whether the architecture can prove that controls are designed, operating, and improving over time. Not every AI system needs the same governance load. A low-risk internal recommender may need light oversight, basic monitoring, and simple records. A moderate-risk system calls for stronger human review, better monitoring, approval gates, and clearer transparency. A high-impact system, such as AI supporting healthcare decisions, needs strict oversight, continuous auditing, security controls, regulatory review, robust explainability, and detailed evidence. The architect's role is to convert risk into practical design choices, balancing innovation, cost, control, and accountability. ISO IEC 42001 is not satisfied by saying governance exists. The organization has to prove it is working. That proof comes from evidence produced across the AI lifecycle: scope, inventory, risk and impact assessments, model documentation, data lineage, monitoring, oversight, incidents, approvals, audits, and management reviews. The design principle is simple. Evidence should not be an afterthought. Architects should build evidence capture into workflows, tools, and decision points from the start. When evidence is generated by normal operations, certification readiness becomes sustainable. When it is assembled manually before an audit, governance becomes fragile. Think of ISO IEC 14001 as the organizing layer for AI governance. It does not replace security, privacy, risk, or regulatory frameworks. Instead, it connects them. ISO IEC 27001 helps secure AI data, models, platforms, and operations. ISO IEC 23894 and the NIST RMF strengthen AI risk practices. The EU AI Act and privacy laws define legal obligations. Enterprise architecture governance embeds controls into standards, review boards, and platform patterns. Together, these frameworks turn responsible AI from a policy statement into repeatable, auditable practice. Consider a simple Gen AI example. An employee asks an assistant, "What is our leave policy?" ISO IEC 42001 makes that interaction governable. First, define the scope: the app, retrieval pipeline, documents, model provider, and business process. Then design for risks like wrong answers, data leakage, prompt injection, and over-reliance. Controls may include access-based retrieval, source citations, filtering, escalation, logging, and vendor oversight. Finally, keep evidence: inventory records, risk assessments, evaluations, monitoring, and incident procedures. That is governance translated into architecture and operations. You've now built the foundation. ISO IEC 42001 is a management system for responsible AI governance, and the AIMS connects policy, risk, controls, evidence, and improvement. Scope defines what is governed and who is accountable. For architects, the standard becomes real through design decisions. Before continuing, choose one AI system and ask, is it in scope? Who owns the risk? And what evidence proves control?